And cool problem here on number 3. A test plane flies in a straight line with a positive velocity v of t in miles per minute at time t minutes, where v is a differentiable function of t. Selected values of v of t from 0 to 40 are shown in the table above. Use a midpoint Riemann sum with 4 subintervals of equal length and values from the table to approximate the integral from 0 to 40 of v of t dt to approximate. Show the computations that lead to your answer. Using correct units, explain the meaning. So always a great idea to sketch our graph in using the points. It says differentiable, which means that the whole thing has to be a smooth curve. There shouldn't be anything discontinuous. So the integral from 0 to 40, we're looking to estimate the area onto the curve using 4 midpoint Riemann sums. So when I sketch that graph in, then we should be able to see if I got 40, each one should be 10. There's my 4 subintervals. So over the first subinterval, I'm looking to estimate this area under the curve. Using a midpoint Riemann sum, here's the midpoint of this subinterval. So there's my rectangle. So the area of that rectangle is going to be, the midpoint was 5, so it should be 9.2 times 10. 10 is our width. So we should be able to quick kind of list in the other 3, sorry. So 15 is my next midpoint, 7 times 10. 25 is my next midpoint, 2.4. Should have gone below. And then 35 is my next midpoint, 4.3. So we add that up, I think we get 229 using correct units. So if I integrated velocity, I should get position. Position should be in, the velocity was in miles per minute, so position should be in miles, approximately, gotta put in the approximate, in 40 minutes of travel. Looks good for part 1. Based on the values in the table, that's so key when they write words like that you just kind of read over. Based on the values in the table, what is the smallest number of instances in which the acceleration of the plane could equal 0 on the open interval from 0 to 40? Justify your answer. So we've got a sketch of the graph, and based on our sketch and based on us knowing from the scenario that it is differentiable, we would say there and there, somewhere in there, we know the answer has to be 2 times at least that it could be 0. Now, we don't know what happens in between any interval. Something crazy could be happening in there. It could equal it 5 times in between. But we know that the minimum number has to be 2 based just on our sketch. But we have to use some calculus words to justify it. The key words would be using the table and saying, because v of 0 equals v of 15 by the mean value theorem, because they are equal, their derivative had to equal 0 somewhere in between that interval. Then, very similar logic, we should be able to circle somewhere between 25 and 30. Again, if the graph is equal at any 2 points and it's differentiable, its derivative had to be 0 somewhere in between there. So the good justification would be, the mean value theorem says there has to be at least 2 instances because they're equal there and equal there. Part C is kind of like a gimme. If you look at the key, it's only worth 1 point. The function is just defined by f of t. Oops. The function is defined by f of t, and you've got that long function, 6 plus the cosine plus the 3 sine, is used to model the velocity of the plane in miles per minute from 0 to 40. According to this model, what is the acceleration of the plane at t equals 23? So I would just plug that into my calculator in radian mode. And I would second calculate dx dt at the value of 23. Your calculator is going to spit out f prime of 23 is negative 0.407 miles per minute squared is what acceleration is in. And that was key. It says indicate units of measure. So 1 point right there. And then according to the model given in C of f of t, what is the average velocity of the plane in miles per minute over the time from 0 to 40? So if we integrate 0 to 40 of the actual function f of t in our calculator, it spits out 236.651 miles. And if I want my average velocity, I would just divide by 40 minutes. So my average velocity should be 5.916 miles per minute. Plenty of work shown here. The integral from 0 to 40 of f of t, we know that's miles. Divide by 40 to find our average velocity. 9 points.